Hi, this is Mrs. LaBarbara. This is AP Physics Mechanics C. Today's topic is Universal Gravitation Review number 2. The question is, a spacecraft of mass 1,000 kilograms is in elliptical orbit about Earth, as shown. At point A, the spacecraft is at a distance of RA, which is 1.2 times 10 to the 7 meters from the center of the Earth, and it's moving with a velocity perpendicular to the line connecting the center of the Earth and RA. That velocity is 7.1 times 10 to the 3 meters per second. We also know the mass of the Earth and the radius of the Earth. So mass of the Earth is 6.0 times 10 to the 24 kilograms, and the radius of the Earth is 6.4 times 10 to the 6 meters. Determine the following for the spacecraft when it is at point A only, so that's important. That's what we want to know, everything at point A here. So first is total mechanical energy of the spacecraft, assuming that gravitational potential energy is 0 at infinite distance from the Earth. So if the universal gravitation is 0 at infinite, so we know anything below that you'll have a negative value. Total energy is K plus U. K is kinetic, U is potential. We know K is 1/2 mv squared. We know U equals negative G little m big Me divided by R. This R is the distance between the center of the Earth and the object. And this is mass of the object. And this is, again, in this equation, K equals mv squared is the mass of the object times velocity of the object. Since you're talking about at point A, so we have to use VA and RA in here. So let's write down what we know. M is 1,000, V equals VA is 7,100, and we know the value of G from reference table. We know mass of the Earth. We also know the distance between the spacecraft and the center of the Earth, which is 1.2 times 10 to the 7 meters. Basically, now all you have to do is substitute all the numbers in, and you get a value. Make sure you'll have your units at the end of the value. Okay, so here is ET, and your value should be negative 8.1 times 10 to the 9 joules. So it's negative. Again, this is because at infinity, the gravitational energy is 0. So anything below that, you should have a negative value. Question B, what is the magnitude of angular momentum of the spacecraft at the center of the Earth? So angular momentum is I omega. I is for a point mass is mr squared, and omega is v over r, so r and r canceled is just mvr. For a point mass, its angular momentum is mvr or mrv. Okay, so you know they are interchangeable. You can exchange that. mrv or mvr are the same. So we already know RA and VA and mass. So you simply substitute everything in, and you should have 8.5 times 10 to the 3. Remember, the unit is kilograms times meter squared divided by second. So for rotation, you add a meter, you multiply a meter relative to the linear, because rotational quantity is all start from torque is Newton times meter. Angular momentum is linear momentum times meter. So you just multiply by meter. Next part. Later, the spacecraft is at point B. So going from A now to B on the exact opposite side of the orbit. At a distance, RB is 3.6 times 10 to the 7 meters from the center of the Earth. Again, this angle, the angle between velocity and RB should be 90 degrees. That should be 90 degrees. Determine the speed VB of the spacecraft at point B. So we know what RA is, we know what VA is, and we know what RB is. You have to find VB. So what concept is this? Do you need to use in order to find VB? That is conservation of angular momentum because there is no net torque on the Earth and the spacecraft system. So angular momentum at A should be equal to angular momentum at B. So MVA times RA equals MVB times RB. This is angular momentum. We kind of like derived in the last question. Substitute everything in. You should have VB equals 2.4 times 10 to the 3 meters per second. Next question. So suppose that different spacecraft at point A, a distance RA from the center of the Earth, determine each of the following. So now it's not this spacecraft, it's a different spacecraft. What is that spacecraft speed if it is in a circular orbit is instead of elliptical? If it's moving a circle like this, what would be its speed? Remember, to find its speed, you'll have to derive it. We know centripetal force is provided by gravity. So from there, we set them equals to each other. You will find speed, the circular speed is square root of gme divided by RA. So we know ME, we know RA, we know G. You simply substitute values. You should have 5.8 times 10 to the 3 meters per second. So as you can see, the speed is different. The speed does depend on the type of orbit. E. The minimum speed of spacecraft at point A if it is to escape completely from Earth. What does this escape mean? Escape means you'll have total energy, you'll have a minimum total energy has to be 0. Because at infinity, your potential energy is 0. So the minimum is at infinity, you are not moving. So that's a minimum energy at infinity has to be 0. Total energy. So you have ET equals K plus U equals 0. We know K is kinetic and U is potential. Substitute everything in. You should be able to solve for V escape. So V escape equals to this, and substituting the values, you should have 8.2 times 10 to the 3 meters per second. And that is called escape speed at that point. Okay, I hope it helps. Thanks for watching. See you next time.